In this video, we are going to discuss about a problem on self-bias circuits. So consider the given problem for the transistor amplifier. VCC is equal to 12 volt, and since the question itself, they have given it is a self-bias and it is a common emitter amplifier. Okay. And you have RC is equal to 1K, given RC is equal to 1K, RE is equal to 1K, and R1 is equal to 8K, and R2 is equal to 4K, and supply VCC is equal to 12 volt, and it is connected to a resistor RL that is equal to 1.5K. Okay. So this is nothing but a coupling capacitors, and this is your VS AC supply. So first we need to find the DC load line. Okay, so in order to find the DC load line, we have to analyze a DC analysis. Okay, we have to do the DC analysis. For this analysis, AC must be 0, and capacitor must be open circuit. Okay, so if I open circuit the capacitance, the circuit will look like this. Okay, the circuit will look like since the capacitors are open circuited, it will not connect it to the output load resistance and the input supply. Okay, so this is your V0, right? So let me find the voltage at VB. So how to find the voltage at VB? So VB is equal to, applying a voltage divider rule, VB is equal to VCC into R2 divided by R2 plus R1. So we know that the value of VCC is 12, and the R2 is 4K, and R1 plus R2 is 12K. So if I solve this one, I will get 4 volt. And what is RB? RB is nothing but R1 in parallel with R2. Okay, so that is 4K in parallel with 8K. So in order to locate so I can read out this equation like this. Okay, so this is your VB followed by RB. Okay, this is your RE, this is RC, VCC, and this is your output. So we know the DC load line will look like this, right? We need to plot it for IC versus VCE. Okay. So for that one you have to solve this equation. So if I solve like this, we will get VCC is equal to ICRC plus VCE plus IERE. Okay, VCC plus ICRC, the current flowing through this one is IC, and current flowing through this one is IE, and this is nothing but VCE. Okay, collector and emitter. So I can write it as IC, I can take it as common, so I will get RC plus RE plus VCE, that is equal to VCC, since IE is approximately equal to IC. Okay, so in the x-axis you know that the maximum value I can find of IC if VC is 0 at this point. So at this point VC is 0. So if VC is 0, what is the value of IC? IC is equal to VCC divided by RC plus RE. Okay, so this is that point. So VCC divided by RC plus RE. In similar way, if you want to find this point, at this point IC value is 0. So if IC is equal to 0, I can write VCC equal to VCE by substituting this equation. Okay, substitute 3 in 1, you will get VCE is equal to VCC. So I can plot this line. So this line is nothing but your DC load line. Okay, so I need to find the Q point. So the Q point is basically a center between the VCC and this point. Okay, so this is your Q point. Okay, so this is what I need to find on solving this equation. Okay, what is ICQ? This is nothing but ICQ, and this is nothing but VCEQ. Okay, first let us find the ICQ value. Okay, so VB is equal to IBRB plus VBE plus IERE. I can write it like this. So if I substitute this point, this is nothing but 12.3, you will get 12.3, and this is nothing but 12. Okay, so here the VB value is 4, this is 4, and generally the IB value is very small, so you can neglect this value. So this is VB is they have given us 0.7, and we know that the value of RE is nothing but 10 power 3. So I can find the value of IE now. IE is nothing but IC, right? So here that is nothing but ICQ. So on solving this one, I will get this is 3.3 milliampere. Okay, so this is nothing but 3.3. Next we need to substitute on this equation. Okay, so in this equation, if I substitute on this equation, substitute this fourth value, substitute 4 in 1. So if I substitute 4 in 1, I will get VCC is equal to ICQ RC plus RE plus VCEQ. So I need to find the value of VCEQ. So VCEQ is nothing but 12 minus 3.3 milli into RC plus RE. What is RC plus RE? So RC plus RE is 2 into 10 power 3. So on solving you will get 5.4 volt. So this is nothing but 5.4 volt. So this is how we have to find the value of DC load line. So next we need to find the AC load line. So for that one you have to short circuit the capacitor. DC supply or to DC supply, that is voltage, you have to make it as 0. So on doing you will get we can find the value of AC load line. So what is VCEQ? VCEQ is equal to VC I need to find, right, for AC load line. That is nothing but VCEQ plus ICQ into RAC. Okay, this is a formula. So IC is nothing but ICQ plus VCEQ divided by RAC. Okay, so what is RAC? RAC is nothing but, so you can see in the diagram, so this R1, this is RC. Since this capacitance is short circuited, so this and this supply is also short circuited. This is R1, R2, RC and RE, and this is VI. Okay, consider in the capacitance C value is also connected. Okay, so since C is connected, this is short circuited, so this resistance is there is no use of resistor here. Okay, so redrawing, this RC comes in parallel with this RL. Okay, if I draw using a H parameter value, H small signal model for the circuit. Okay, so this RAC is nothing but RC in parallel with RL. So in that case this value is 0.6K. So if I substitute this values, I will get VCE is equal to 7.38 and IC is equal to 12.3 milliamps. So if I draw this one, sorry, this one is 6. And so if I draw this one, I will get AC load line value, which will pass through this Q point only. So this is your AC load line. And the value of ICQ is 12.3 milliamps and this one is 7.38 volt. So this is how you have to draw the C. They have given in the question also, make a change. C values given as C is also connected. Okay, so this is how we have to solve this problem. So next problem, BJT which is having a base current IB is equal to 200 microamps. You can see the base current is very less, and alpha is equal to 0.99, and ICB not is equal to 10 nanoampere. So we know that IC is equal to alpha IE plus ICB naught. So on solving this values, this is for common base configuration. Okay, common base configuration, and similarly for common emitter, this is IC it is equal to beta IB plus IC E naught. Okay, so this is for common emitter configuration. So what is IC by IE? IC by IE is equal to alpha. So what is, if I divide the whole term by IC by beta, that is equal to alpha. What is IC by IB? IC by IB is nothing but beta. Okay. And what is IE? IE is nothing but IC plus IB. So IC divided by IB is into IB by IC plus IB. That is equal to alpha. Okay. So I can write IB plus IC plus IB is equal to alpha divided by beta. So what is IC plus IB divided by IB? That is equal to alpha divided by beta divided by alpha. So IC by IB plus 1 is equal to beta by alpha. So this is nothing but beta. So beta plus 1 divided by beta is equal to alpha, 1 by alpha. Is equal to 1 by alpha. So what is alpha now? Alpha is equal to beta by 1 plus beta. So similar way, so if I solve what is beta? Beta is equal to alpha divided by 1 minus alpha. Okay. So this just I am deriving the expression for this one. So if you know already the expression, you can simply solve this problem. Okay. So this expression I can write it as IC is equal to beta IB plus beta plus 1 IC B naught. Okay. So given alpha value, so from this I can derive the value of beta. So what is beta? Beta is equal to 0.99 divided by 1 minus 0.99. That is equal to 0.99 divided by 0.01. So multiplying the whole term, I will get beta is equal to 99. So you substitute here 99 into IB. What is IB? IB is 200 micro plus 201 micro into ICB naught. ICB naught is 10 nano. So take a calculator. So 200 into 99. So 19800 micro plus 10 means 2010. This is 10 power minus 6 and this is 10 power minus 9. So you will get 10 power minus 6, 9 means 10 power minus 15. So this is very less value. So here you have 19.8 milli I can write, plus this one 2 into 10 power minus 12 I can write. So this is almost equal to IC's 19.8 milliamps. Okay. So that's all about the problem. Thank you.